Okay, here we're in part 2, and we're still with substitution. So what we need to do is solve this for one of the variables and substitute it into the other one. And so looking here, all of them look like we're going to have fractions no matter what way we do it. This one has the smallest number to divide by. So what I'm going to do is I'm going to take that and solve for y. So if I do that, I'll have 2y equals. Now I'll take everything else to the other side. So that's going to be 5x plus 6z equals 3. Oh, plus 3, sorry. We better make that so I can read it. All right. And now we have to divide everything by 2. And so y is equal to 5 halves x plus 3z plus 3 halves. Okay. Now I can substitute this into the first equation and the third equation, and that's going to eliminate my y, and I'll be left with two equations with x and z only. So let's do that. So when I do it on the first one, I'll have 4x plus 6 times, and then I have 5 over 2x, and then plus 3z plus 3 halves, and then I have plus 9z equals 0. And over here I'll have 7x and then minus 4 times y, which is 5 halves x plus 3z plus 3 halves, and then I have still plus 3z, and that equals negative 3. And now to simplify. So now I have to distribute my 6 through, and here I have to distribute my negative 4 on through all of them. And so don't forget to do that last one as well. And so I have 4x and then plus, now we have 2 will go into 6, 3. So we have 3 times 5, so that's going to be 15x. And 6 times 3 is going to be plus 18z. And 2 will go into 6, 3. So we have 3 times 3, so that's going to be plus 9. Then plus 9z. And then that equals 0. Okay, now here, what we have is we have a 7x, and then we have, looks like minus, and then when 2 will go in here twice, so we have 2 times 5 is 10, so minus 10x. And here we have minus 12z. And here the 2's will cancel, and we have a minus 2 times 3, so it's going to be a minus 6. And we have plus 3z equals minus 3. Now we add like terms, so we have 4x, 15x, 18z, 9z, and we'll take the 9 over. So we have 4x plus 15x, so that's 19x. And let's make it so it's readable, or we'll write the wrong problem. So that was 19x. And then we have 18 plus 9, so it's going to be plus 27z. And then that equals a negative 9, because we're going to subtract it from both sides. Now, what do we have? Well, now we have a 7x and a 10x, so it's going to be a minus 3x. We have a minus 12 plus 3. So that's going to be what? A minus 9z. I'm going to add 6 to both sides, so that equals 3. Okay. So now what do we do? Now what I'm going to do is I'm going to say, okay, well, these are my two equations that I'm working with now. Two unknowns, two equations, and so let's eliminate one of them. The 3 and 19 are both prime, so we can't do anything there, but 27 and 9, I can get to the 27 by this one, so I can multiply this equation by 3, and I get a negative 27. If I add it to that, then I eliminate the z's, and I'll be left with the x's. So that's given me 19x plus 27z equals negative 9, and if I multiply here, that's a negative 9x, and then minus 27z equals a 9. And so those cancel. Well, guess what? Those cancel too, so I get 0 there. And 19 minus 9 is going to be 10x. Well, that's going to be divided by 10, so x equals 0. So that's nice. because then I can plug that into maybe this equation and get a simple answer, okay? So if I do that, I'll have, well, plug in 0 there, it's a minus 3 times 0, minus 9z, and that equals 3. And so that's gone. Now I just divide by negative 9. And so z is equal to a negative 1 over 3. Okay. Now I can plug in and solve for y. And so now I can say, well, y is equal to 5 halves times 0 plus 3 times negative 1 over 3, and then plus 3 halves. Okay. Well, that gives me, well, that's 0. This is going to be minus 1 plus 3 halves. Well, 1½ minus 1 is just y equals 1/2. And so that gives me the ordered pair 0, 1/2, negative 1/3. Okay. Now, if we're going to check that in all the equations, we're going to have to plug that all back in. And so we had 4 times, and now let's write down our, it was a 0, and then we had 1/2 and negative 1/3. And so we'll have 4 times 0, and then we had plus 6 times 1/2, and then we had plus 9 times negative 1/3 equals, that was supposed to be 0, so that's 0. So here that becomes 3, and this is going to be minus 3, and so 0 equals 0, so it works in the first equation. Now the next equation is a minus 5 times 0 plus 2, whoa, 5 times 0, and then plus 2 times y, which was the 1/2, and then a minus 6 times negative 1/3, and that's supposed to be equal to 3. Well, that's 0. So 2 times 1/2 is 1. And then the minus times the minus is plus. 3 goes into 6, 2. And so 3 equals 3. Well, that works as well. And then our last one, we had 7 times 0. And then minus 4 times 1/2. And then we had plus 3 times negative 1/3. And that's supposed to be equal to a negative 3. Well, that's 0. That's a minus 2. And that's going to be a minus 1. And that's minus 3. So minus 3 equals minus 3. That works. And so our solution really is 0, 1/2, negative 1/3. And so that would be our solution to this system of equations. And again, we solved by first starting with substitution. We solved one of the equations for a variable, plugged it into the other 2 equations, and worked our way down. And then we did our check here. So this is the check on all 3 equations. All right, so the next one we're going to actually do is says, well, let's do this by elimination, okay? So we want to think about which one we want to eliminate here. Now, if I'm looking at this one, I have a 2 from the last one, it looks like still. I can get from here to here by multiplying by 3, and I can get from here to here by multiplying by 2. But going the other way, it's not going to be easy. So I always start with the equation that's the smallest numbers and see if I can get to the other 2. So I think then what I'm going to do is I'm going to multiply this by 3 and then add it to number 2. And I'm going to multiply this by 2 and add it to number 1. Okay, and so that way I'm going to get eliminate the x variable, and I'll have 2 equations in with 2 unknowns. All right, so if I do the first equation first, I'm going to have 4x plus 6y minus 2z equals 8. And then if I take this times the 2, I'll have a minus 4x minus 6y, and then it'll be plus 2z, and that equals a negative 8. Well, if we notice here, we get 0 equals 0, okay? So really, we're done at this point, but let's go ahead and look at this one here. If we multiply this by 3, that's going to be a negative 6, so those would cancel. Multiply that by 3, that would be a negative 9, those would cancel. those would cancel, and those would cancel. So it didn't matter which one I did first. So let's go ahead and show that. And if we multiply by 3, we're going to get minus 6x minus 9y, and then plus 3z equals negative 12. And at the same time, I get 0 equals 0 because everything cancels. So what does that say? Well, that says we get an infinite number of solutions. Now, if you remember from the last one, we had a general kind of values for plugging it in. We didn't get a 3, 4, 5 or anything else. We wrote equations down. So in this one, what we have to really do is we're going to plug in some x, doesn't matter. We're going to plug in some y, doesn't matter. And now what we're going to do is we're going to solve one of these for z. Now, if I look at these, which one do I want to solve for z? Well, I would solve this one for z, and that would give me z equals. Now I take the 2x over, so that'd be 2x. Take the 3y over, so plus 3y. And then I have minus 4. And so then I have 2x plus 3y minus 4. And that would be my general solution to this. Now, if it asks just, you know, if it has infinite number of solutions, write that. And if it asks to put a general formula, that's kind of what you would want to put there. So you'd have your x and your y, and you can just choose any of them, and then you get your z out based on whatever your x and y are. Okay. So that's how I would do this one, solving by elimination. All right. So what about the next one? We have 10x plus 2y minus 14z equals 8. Then we have the minus x plus minus 2y minus 4z equals negative 1. And then that minus 12 minus 6y plus 6z equals negative 12. So looking at this, what would I do? Well, I could easily get from here to here and here to here. But that would be multiplying by a factor of 10 and multiplying by a factor of 12. Now going from here to here, well, that one I could just add the two equations together and I wouldn't have to do anything. And if I did these two, I'd have to multiply by -3. So I think that's what I'm going to do. I'm going to just take and add those two together to start with. And so that's going to be a 10x plus 2y minus 14z equals 8. And I have a minus x minus 2y minus 4z equals -1. And then I'm also going to take this equation times a -3 and add it to number 3. So I'm going to take a -3 times that, and that's going to give me a 6y, then minus 6y. That'll get me rid of that one. All right, so then if I do that, I could do that up here. So -3 times that's going to be 3x plus 6y, and then it's going to be plus 12z equals 3. And the last equation is minus 12x minus 6y plus 6z is -12. All right, so now I've got two eliminations going on. Eliminates here, and this one eliminates here. And so I'm left with x and z and x and z. So that's what I initially wanted to do. So 10 minus 1 is 9x. Minus 14 minus 4, so that's a minus 18z. And that's equal to 8 minus 1, which is 7. Okay, and maybe I need to write that a little bigger. All right. So then what do I do? Okay, well now I have to come over here and I'm going to say, well here that's going to be 3 minus 12, that's a minus 9x. And then that's going to be plus 18z. And then it's going to be 3, that's going to be minus 9. Okay. All right, well now I notice if I add the two equations together, my 9x will cancel the 9x. And so these two I'm just going to add. So I'm going to take the 9x minus 18z equals 7, and minus 9x plus 18z equals -9. Well, guess what? Not only do those cancel, but those cancel, so I get 0 equals -9 plus 7 is -2. Well, what does that tell us? That tells us we don't have a solution, so that's false. And so there's no solution to this system of equations, okay? Now again, you can't show any calculations to do the check, and so when you get a no solution, then you just have to say, okay, well, I have to trust myself that I've done all the calculations correct and go from there. All right, so that's into part 2. I'll be back with part 3.